In a factory setting, power cords are an essential part of electrical systems that provide electricity to machines, equipment, and other devices. The process surrounding power cords in a factory can be broken down into several key steps. 1. Design and specification. Power requirements. The factory determines the power requirements for each piece of equipment. This includes the voltage and amperage needed to run the machines or tools. Cord selection. Based on the power specifications, the appropriate type of power cord is chosen. Factors such as cord length, insulation, and wire gauge thickness are considered to ensure the safe delivery of electricity. Regulations. Power cords in factories must meet safety standards, often outlined by regulatory bodies, like OSHA or the IEC. The cords must be designed to handle the factory's specific operating environment, temperature, chemical exposure, moisture, etc. 2. Manufacturing and assembly. Cable materials. Power cords are typically made from copper wires for conductivity, and rubber or PVC for insulation to prevent electrical shocks or fires. Some factory environments may require cords with specialized coatings for additional protection against heat, moisture, or chemicals. Stranding and insulation. The copper wires are stranded to make them flexible, and insulation is applied to prevent short circuits. The insulation also serves to protect workers from electric shock. Molded plug. Throughout the manufacturing process, the cords undergo testing for things like continuity, strength, and resistance to heat, moisture, and pressure. 3. Installation and use in the factory. Distribution. Once the power cords are manufactured, they are distributed to the various areas of the factory where machinery and electrical equipment require power. Connecting to power sources. Power cords are connected to wall outlets, extension cords, power strips, or directly to electrical panels, depending on the power needs of the machines. Routine checks and maintenance. Regular inspections of the power cords are essential to ensure they remain safe to use. This includes checking for signs of wear, damage, or fraying of the insulation. If any power cord is found to be faulty, it is replaced immediately to avoid the risk of electrical hazards. For safety and compliance. Grounding. Many factory power cords have a ground wire that helps protect equipment and workers from electrical surges or faults. Circuit breakers and fuses. Power cords are often connected to machines that have built-in circuit breakers or fuses, which are safety devices that disconnect the power in the event of an overload, preventing damage to equipment and minimizing fire risks. Training. Workers must be trained in safely handling power cords and recognizing faulty cords. The proper use of extension cords and the importance of not overloading circuits are critical aspects of maintaining safety. 5. End-of-life recycling. Disposal. Once a power cord is damaged or no longer in use, it must be disposed of properly. In some cases, cords can be recycled, especially the copper wiring, to avoid waste and minimize environmental impact. Recycling programs. Some factories or regions have dedicated recycling programs, where old power cords are sent to be stripped of their materials and repurposed. 6. Types of power cords used in factories. Different types of power cords are used based on the environment and application. These include heavy-duty cords. In factories, heavy-duty cords are used to power large equipment such as industrial machines, conveyor systems, or pumps. These cords are typically thicker, with higher amperage ratings, and made from materials like rubber or thermoplastic elastomers, TPE, that can withstand rough conditions, including exposure to oils, chemicals, and extreme temperatures. Extension cords. Often used when the equipment cannot be located directly near an outlet or when temporary power connections are needed. They need to be rated for industrial environments and able to handle higher power loads. Portable cords. These are used for tools and machinery that need to be moved around the factory floor. Portable cords are often flexible, durable, and resistant to abrasion and bending. Flexible cord assemblies. These include specialized power cords that come with factory-specific connectors for easy and secure connections to equipment. They are often used in robotic systems or automated machinery. High-voltage power cords. For some industrial equipment, power cords need to handle higher voltages, for example, 480 volts or 600 volts. In addition to standard 120 volts or 240 volts, these high-voltage cords have specific safety ratings and insulation designed to prevent electrical shock or fires. 7. Environmental considerations. Factories often operate in environments where external conditions can affect the performance and lifespan of power cords. Some challenges include Temperature extremes. Some factories work in high-temperature environments, for example, metalworking foundries, or factories with large ovens. In these settings, power cords must have high-temperature insulation, often rated for temperatures up to 90 degrees Celsius or higher. Chemical exposure. In certain industries like chemical manufacturing or food processing, power cords must be resistant to chemicals, oils or special coatings or materials like chlorinated, polyethylene CPE and thermoplastic elastomer, TPE are used to resist degradation in these harsh conditions. Moisture and water. Factories that deal with wet conditions, such as in breweries, pharmaceutical factories, or food processing, require waterproof and moisture-resistant power cords. These cords are often constructed with waterproof materials and designed to be safe in environments where they may be exposed to water or cleaning processes. 8. Automation and smart power cords. With the rise of Industry 4.0 and automation, some factories are beginning to incorporate smart power cords and systems. These include integrated monitoring. Some modern power cords are embedded with sensors that monitor the current and temperature in real time. If the cord overheats or if there's a potential overload, the system can trigger an alarm or shut down power to prevent accidents or equipment failure. IoT Internet of Things connectivity. In some advanced manufacturing settings, power cords can be part of an interconnected system that allows for remote monitoring and diagnostics. This means that factory operators can monitor the health and safety of power cords remotely, making it easier to spot potential issues before they lead to failures or downtime. Energy efficiency. Smart power cords can also help track energy consumption. This data can help optimize factory energy usage, leading to more efficient operations and reducing overall electricity costs. 9. Durability and wear. Over time, power cords in factories undergo wear and tear due to constant handling, movement, and exposure to rough environments. Some common factors that cause damage include abrasion. The constant friction of power cords being dragged or moved around can cause the insulation to wear down, which may expose the internal wires and increase the risk of electrical shock or short circuits. Bending. Repeated bending and flexing of power cords can lead to fatigue of the conductors inside, eventually causing them to break or short out. Pinching and crushing. Power cords that get pinched in doors, equipment, or machines can have their insulation compromised, creating potential hazards for electrical shock or short circuits. Exposure to high stresses. Some equipment in factories may be subject to vibration, impact, or mechanical stress. In such cases, cords with specialized abrasion resistance, strain relief features, and reinforced construction may be required. 10. Maintenance and troubleshooting. Proper maintenance is key to preventing power cord failures. Some aspects of cord maintenance include regular inspections. Technicians or safety officers perform regular visual inspections of all power cords. They check for signs of fraying, exposed wires, burns, or any other visible damage. Testing. Factory personnel often use testing equipment such as multimeters or continuity testers to check whether power cords are functioning properly. These tests can detect issues like broken conductors or poor connections that may not be immediately visible. Repairing versus replacing. In some cases, power cords that are damaged may be repaired, especially if the damage is localized, for example, a small cut in the insulation. However, it's often safer and more cost-effective to replace heavily damaged or old cords rather than risk ongoing issues. 11. Training and safety protocols. Given the hazards associated with electricity, factories must provide regular safety training to all employees who handle or work around power cords. This training typically covers safe handling. Employees are taught how to properly handle power cords, especially when connecting or disconnecting them from outlets or machinery. Avoiding pulling the cord by the cable, using the plug to disconnect, and avoiding tangles are emphasized. Identifying hazards. Workers are trained to recognize faulty power cords, including signs of wear, burns, and improper grounding. They learn the correct procedures for reporting and replacing damaged cords. Personal protective equipment (PPE). In some environments, workers might need to wear gloves, insulated footwear, or other protective gear when handling electrical equipment to reduce the risk of shock.